Update.com, we look up into the sky. We bring you exclusive footage from eclipses worldwide. We take our mobile observatory to where the action happens.
Hi, Stefan.
We bring you exclusive footage from eclipses worldwide. We take our mobile observatory to where the action happens.
Labs, these optical benches and tables to get this precision, to get the temperature exactly right, to hone down these observations and anything like the vibration that you were talking about to stop them affecting them. I mean, this is technology and engineering at a level which probably surpasses most areas of commercial engineering and a lot of scientific measurement. And I think that's what most areas maybe excites a lot of students who want to get into technology and science and astronomy. And it's really finding these niche areas where we're going to the extremes of what's possible. Is that one of the things that attracted you to both astronomy as a science, but also your particular field?
Yes, see, I was always interested in astronomy as a child. I mean, looking at the stars was amazing, and I think it's still amazing for many kids. And I sometimes attended some popular astronomy talks. So this was really interesting for me to know. But yeah, as you mentioned, it's very correct that students who would have interest in science would like to maybe look at the physics side of looking at stars, which I'm more interested in. Whereas when we build instruments, we definitely need to have a very, very strong team of engineers. And this is where many other people who are not into the scientific direction, but they're looking at the technical direction, they can also contribute a lot. And so it caters to different fields of interest, I must say.
So there is a huge opportunity for students who are interested in technology, engineering, math, physics, all of these different branches of STEAM, to get involved with this kind of, I know it's a cliche, but this kind of cutting edge, this leading edge technology. To finish off, Priyanka, if we've got students watching today, either in India who are tuning in for the first time or elsewhere in the world, and they think to themselves, actually, I'd like to do what Dr. Chaturvedi does. What advice would you give them? What do they need to do to pursue a career like yours?
I must say that if you want to make a career in astrophysics, I must say do your physics and math seriously. That's the first advice at school, I think I must give. And don't worry to take risks. I mean, people must take risks. When I started in my graduate school as an optical astronomer, I must say I was the only girl going for observations, and there was nobody else joining me at that time. I mean, there were other people, of course, but there were no other girls joining. But if I would have been just scared and not decided to do this, I would have missed such a wonderful opportunity. So I think just don't worry and go ahead.
Well, you are an absolutely fabulous role model, not only for any student, but for female students in particular, to follow. And it's working hard, it's being focused, and I know you would not have got to where you are today without being very focused and maybe slightly ambitious as well. So we wish you well for the future. Thank you so much for joining us today and telling us about your work as an astronomer. Just one last comment from you about what we're seeing today. It's pretty special, isn't it?
Yeah, yes, definitely. And I'm really happy to be here on this show, and I wish you all the best.
Well, thank you very much, Priyanka, for joining us, and we hope to see you actually on another Sleuth show very soon. So take care until then. Thank you for joining us.
I'd be happy. Best wishes.
Now,
Bye-bye.
don't go anywhere, folks. We are going to have after this. We've got about a 5-minute break now. We have got Divya Krishnamurthy, who is our SLU in India ambassador, joining us after the break, and she's going to tell us a little bit more about SLU's launch in India today, which is really, really exciting. And it's not just for schools and colleges in India, it's also for normal folk like you and I to enjoy the sky every night. And already there's a nice little community growing in SLU of members from India. So it must be getting a bit late in India now. So thank you very much for staying up with you. But join us after in about 5 minutes time when I'll be joined by SLU's Indian ambassador, Divya. So don't go anywhere. Keep an eye on these live image streams. Look at that. It might be a small black dot, but it's our small black dot, and it's Mercury. It's celestial mechanics in operation. And what do you reckon? Nearly a third of the way, I guess. Got another few hours yet to go as we see Mercury cross the face of the sun. I'm excited. I'm always excited when I see pretty pictures. You know me by now. I'm like a dog seeing squirrels. But anyway, don't go anywhere. We'll be right back after this break for about 5 minutes. Bye for now.
How amazing is that? That the transit is happening while the sun is right there in the handle of Libra. How absolutely amazing is that? You guys can hear my voice okay right now, right? Is it going to be through a telescope? Well, yeah, Sean, I'm kind of bouncing around between other people live streaming, and this is my Stellarium program right now. Yeah, Allison, you can hear my voice? Cool. This is my Stellarium program right now, and my Stellarium is set on my exact location, and it's not just an image. I mean, as you can see it floating by, Stellarium keeps track of everything in the sky in real time. So I just wanted to check what Stellarium had to say as to where Mercury was. When you say a little bit louder, do you mean my voice or do you mean the music? Because that's not my music. Like I said, I'm sort of piggybacking other people's live streams. A couple of different YouTube channels are live streaming from various observatories. And I'm just sort of bouncing around, keeping an eye on. I'm hoping I don't get like a copyright strike because I'm using other people's materials and other people's music, so this really isn't about the music. But this is, let me see, having trouble reading that. Where is this one actually located? Hey Deans, haven't seen you in a while. But because of my location and because of other locations around the globe, the position of Mercury will be slightly different. Here's my Stellarium.
Hello and welcome back. I keep saying it, don't I? Welcome back to the celestial event of 2019, the transit of Mercury. You are going to have to wait until 2032 to see another transit of Mercury. If you're in the USA,
See,
you're
like
not going to
this
get a
one right
chance to see one
here
from your
is
own backyard
from
until
Norway.
the 2040s. And I understand, actually, a lot of you cannot see it from your own
I think that's
backyards
it
in
right
the USA
there.
today, both on the West Coast and the East Coast and across the entire United
So,
States, because you've got some
depending on
pretty
the
poor weather
latitude
there.
where you're
We've
viewing
got
it,
some great weather down in Chile at the moment, so we've got
show a
our Chile feed
slightly
up and running
different
from our
position
partners down there at
because
the
of the rotation.
Institute of Astrophysics at the Catholic University. There's their feed now. Let me just show you where Mercury is. It's not easy to see in this feed, but we've got a full view of the sun. Now, just right or lower right of center, you'll see a little smudge.
There.
That is Mercury. So if we go back to our live feed from SLU's flagship observatory, the Institute of Astrophysics of the Canary Islands, it's a lot easier to see.
Canary
there it is through our
Islands?
special telescope. Now, this telescope,
These guys are watching it from the live observatory from the Canary Islands.
We're going to be talking about some of the aspects that we can see in that, some of the phenomena like prominences, huge plumes of superheated plasma spewing out from the surface of the sun, sunspots, active regions, plages, which is French for beach. Who knew that there were beaches on the sun? All manner of things. That's what
beaches on the sun
every single day. But in this view, we can see just left of center there, that tiny black spot is Mercury, that hot little planet orbiting the sun, so close to the sun. And just by some cosmic coincidence, some cosmic celestial mechanics and alignments, we get to see it today crossing the face of the sun. Not even halfway yet. But anyway, I said right at the outset of the show, we are
this
big
is supposed to last for like 5 hours.
We are launching SLU in India today. And I'm delighted to welcome our special guest today.
How often does it transit?
In India.
Well, it's not a regular thing.
Murthy.
The next time is going to be 13 years from now.
Hi.
2032.
Hi. Thank you, Paul. You're so sweet. And
these guys. The next one's supposed to be 13 years from now. Mercury has an 88-day orbit, but the plane of ecliptic that Mercury orbits the sun is different than our plane of orbit. So it's kind of a rare thing. I think the last time Mercury transit the sun was in 2016, and the next one won't be for another 13 years. I wonder if the flat earthers can have that kind of prediction. But I thought that was cool because of the way that the Stellarium works. that I can pull up any planet or any constellation. And I thought it was a cool, really cool coincidence, kind of a coincidence, I guess, or some significance, that the sun is dead center on the handle of Libra during this transit. I wonder where Jupiter is right now, just for curious. Oh, it's below the horizon. Let me see. If I get rid of the ground, I think atmosphere. Which one is it? I'll just go ahead and turn on all planet. Wait a minute. Turn it. Oh, there. Now they're on. That's the ground. Get rid of the ground. There's Jupiter. So Jupiter is inside, almost inside the leg of Ophiuchus. Venus is in the claw of Scorpio. That's interesting. But look where the sun is, right on the handle of Libra during this transit. That's awesome. Look at all these numbers cranking. All the altitude, longitude, latitude, all the directional lines as the whole sky moves overhead. That's pretty awesome. You need my volume up. Well, my voice volume probably won't go up any more than that. The volume on the channels that I'm checking here, like these guys, I can turn that up if you want to hear what they have to
For
say.
next 5 years. It's going to be happening in next 5 years, and in fact, we'll be also launching a project to explore the interstellar space called ExoWorld. So this
You
shows
guys,
how
I'm
our
sitting in
country
front of
is giving importance to the space.
I'm sitting in front of my wood stove. I got the fireplace going. It's a little chilly in here, and I think that the voice canceling or the noise canceling part of my headset has probably got my microphone turned down because my fireplace blower is making a lot of noise behind me. So I don't think I can get any more volume out of my voice here. Not that it matters.
And
Can you
daily
guys hear
students will
these
be like,
people talking?
trying to find different resources to gather information, not only from the textbooks, but also some resources, especially what SLU produces. So they can use those knowledge, and they can use it to
Cool.
understand how our solar system works. And we want a reliable resource. It's not like, we just Google about Mercury, we'll get 10 different contents popping up. And we want a reliable resource to find and understand the system completely, because space is interesting, but it's complicated.
Yeah.
So
And but
yeah.
isn't that what's wonderful about astronomy to start off with as a science? It's very accessible. But that's where I think
Yeah.
SLU comes in, that live astronomy, and you start taking live telescope views like this, but of
This is a
nighttime
real-time
objects
simulator on
directly
this
into a
page right
classroom.
here because I guess they're
That has to be way more inspiring and way
live
more
streaming this.
engaging
I don't know.
than
Maybe they can't
looking it
pick up
up on
the
Wikipedia.
some
You
of the
know, when
observatories.
you've been sharing a lot of your images that you've
Yes.
been taking and
But this
snapping
one
from
is
your
cool
live
because
missions at
it's
SLU.
from
And they're
Alisund,
yours. It's something that
Norway.
you've done, that you've captured. But then you were talking about these quests that
There
are
it is
coming
right
out, and the
there, a little blurry.
activities that are coming out for schools and classrooms, over this year, by the end of the year. And that means that
Yeah.
students can take this data and then do something with it. It's building their inquiry, and it's aligned to all the NGSS curriculum as well, which is kind of, although it's a very much a
So
North
they've got their
American
timestamp
standard, it
down
is
here,
being used
1430
elsewhere around
hours.
the
That's
world as well. So live
2
astronomy, how
o'clock
important do you think that
from
live
Norway,
aspect is to get that into classrooms, Divya?
2:30 Norway.
Back when I was a student, I had no opportunity,
That's very
had
cool.
no internet. It was really difficult,
I don't know. I kind of
but
wish
still
Influence
I
Freedom
could
was around right now.
um,
She would be able to tell better than that,
understand
better than
and
me, Allison.
do things just by referring textbooks.
But I do
So
think there
at
is
this time, at this
probably some
generation, with
significance
all
from
these slew
astrological
feeds in the
terms because,
classrooms,
like I said,
will make the
the
students
sun
more involved and involved in the science and
is literally
all these small
right
kids coming
in
up with
the
the
handle
projects. You have no
of
idea how
Libra, which
beautiful they are
I think is,
creating stuff.
I mean,
So
it could
this
be anywhere, but look
creativity
where it
skill
is, right dead
will
smack
be
on the
much
handle.
more needed for the younger kids, and bringing
Meteor
astronomy
shower
live
tonight?
to the
Cool.
classrooms will help students a lot more
Not the
interactive
Orionids. Which one?
and a
Which
lot
one is
more
tonight?
practical. So
Yeah.
there is a difference in seeing a nebula in the textbook and seeing it in the live telescope, in the current view.
Yeah.
And
And
yeah,
I think one of the things that you broach there is something that we hold very dear at SLU. And, you know, a lot of our viewers there will be thinking, oh, it's all going to be a bit geeky, a bit sciencey for me. That's not, you know, I'm not that much of a geek or a nerd or whatever. But we don't, SLU doesn't see astronomy in the confines, the rigorous confines of science and math
yeah,
and physics. We're interested in the artistry of it. We're interested in the
exactly.
cultural aspects. And in fact, I'm talking to the astronomer that I'm talking to a little bit later. We're going to be talking about astronomy in culture
There she is.
in
Wow.
India, you know, over
Mhm.
millennia. And the early observations that were made, and how that
Hey,
relates
Influence. Good
to
morning to
the
you. What's going on?
spiritual
What do you think,
and the cultural
Influence?
and to
Did
literature
you catch this
and
when I was
art. You
showing
know,
that
you've
the
seen
sun is
and
like
you've been
smack in
doing
the
some of this
handle of
yourself. You've been
Libra?
processing your own slew images,
And I
not
was
for a
checking to see where
scientific
Jupiter
purpose,
was.
but from an artistic
Jupiter's in the leg of
perspective. And it's
Ophiuchus.
all of these, it's the way we tie, I think, science into other aspects, other topics, other subjects in the curriculum that helps engage a wider group of students, and hopefully that sounds like it's going to be very useful in Indian schools.
Yeah, of course. And the second thing, in adding to your note, um, the the creativity I meant will also not limited to oh, I don't like space, so it's not going to be interesting. So it doesn't mean that way.
Mm,
It's a different, as you said, it's a creativity. When you see a nebula, how beautiful view,
mm,
and and we can just animate and see how extreme we can bring its extreme it how we can bring its extreme level of the view. And
yeah.
it's really interesting. And Paul, you know something? People used to ask me after I joined SLU. People used to ask me, "Oh, you are an astronomer. You did an astronomy course and stuff like that." I used to tell them, "See, I have no idea on the celestial objects and stuff." But when I joined SLU, I had no idea.
Mm,
I just know what are the planets and something like that, basics. So SLU guided me each step, and how a star look and what is the formation and how the planets are arranged and how the nebulae is formed, and
mm.
so many contents. As a fresher, as a
You
new
guys remember
person for SLU, it really helped me to explore.
when the Great American Eclipse happened? They were handing out, or you could buy like for $2, those solar filter, those glasses. They were like 3D glasses that you get at the movies, those paper glasses that had solar filter material. I took, we had an extra one, and I tore the lens off of one side, tore the earpiece off just so I had this little paper lens, and I took some tape and I taped it on one side like as a flap, and I put it on my cell phone, and I actually used my cell phone to film the eclipse, and it worked perfectly. That lens worked perfectly over the digital lens of my cell phone to get a really good eclipse. I'm thinking I might, because I still have it, I might go outside and get my little tripod and see if I can get my cell phone to zoom in enough. I don't have like a good digital camera. I don't have a P900 or anything like that, so I wonder if I use that filter again, because I was literally able to look directly at the sun with my cell phone and see the eclipse perfectly. I just wonder if I could get my cell phone out there. It's a little chilly out right now, and we got several more hours for this to go on. I'm going to try in a little while, see if I can get my cell phone to even get a glimpse of it. That would be cool. And I think we're supposed to be a full moon tomorrow also. Yes, and it's 11/11 on Veterans Day, no less. Exactly. Veterans Day. Yeah. Of course, if I do get anything off my cell phone, I'll have to upload it. I won't be able to. It won't be able to have it like part of this live stream here. So long, and thanks for all the fish. Right. It looks like Stellarium has got that thing pegged exactly where this observatory has got it. So they're dead on right there. But again, it depends on the latitude. If it's off at all, it's because of the observation point. I don't know if you guys remember when I spoke with Steep Six on the show a couple of weeks ago. He had some observations of the moon, some photos that he took of the moon when he was in Australia, and then he traveled to Europe, and he was in Paris, and he took some pictures of the moon, and they rotated. He said, you know, by his word, unless he was bullshitting me, he said that he kept his camera level. He wasn't tilting his camera or twisting it or anything. And the images he got, we compared them. In fact, I might even be able to find them. Let me see here. Where did he go? Steep Six. Where did they go? They were like way up here. He sent me all these. There they are. There. Like, yeah, pay attention to the orientation of the moon here. I thought I was able to get two of them open at once. Oh, there we go. I can just switch back and forth. Like, notice the craters like this one right here. And then when he goes to Paris, and then we estimated that it might be a roughly 70-degree angle change. And then when we check the globe or we check the map, that the latitude difference from where he was in Australia to where Paris is about 70 degrees, and so that makes perfect sense that the observation, that the angle would change. So that's why I say when I look at Stellarium, if there's any difference in the location, then that's because of the latitude of different observation points, which is pretty awesome. That's a virtual there. Like this is Norway. Uh-oh, they're getting some clouds rolling in. I think that's it right there. Yeah, there it is. Right there. Right where my mouse is pointing. So let's see, I think that's it right there. Right there. Pretty darn close. They're not too far in latitude from where I am, I guess. Yeah, I muted the other video, the other stream here. These guys talking. If you wanted to hear what they have to say, they stopped talking. I guess they're going to take a break. I got some music going right now. Run around. Mars is with Virgo. Yeah, sure is. There's Mars right there in Virgo. That's awesome. There it goes. I love this program. You can zoom so far in. It's pretty amazing. Let's see if I can find who else has got it. joined NASA. Let's see what's going on here. Looks like they're looping a high speed on a loop. When it gets to the point where it is now, it stops and goes over again. Right about here. Yep. Pretty sure that's not an animation. They're saying here that this is we joined NASA to follow the Mercury, so okay. Yeah, they're just high speed looping where it is up to where it is now. That's pretty cool. Not seeing much in Norway right now.
Gamer. Hello, Bob. How are you? You're back.
Yes, I'm back. Great to be here again, Paul.
So we're talking about cycles now, and the cyclical nature of guesting on this show. So we were going to talk about the solar cycle, Bob. What is it, and how does it relate to what we see on the sun, and how does it relate to the climate on Earth? Does it have any impact? So,
well, it's true because
Jeremy.
What we're staring at, of course, is a black
Jeremy,
dot
nice to
against
see you.
a pretty blank sun. This is not usual because normally there are a lot more sunspots.
There you go. Now you can add links or kick people out if you're so inclined, Jeremy.
When Galileo started observing the sun, along with Christoph Scheiner, a Jesuit German who is also an observer, and boy, they went at it for years and years about who is first to notice that the spots change position and therefore revealed that the sun rotates. It seemed hard to believe, but that's part of the cycle. Everything is moving from left to right across the face of the sun. And could it be that the sun spins around in the same period that the moon spins around? Now hold on. We've only got two disks, two circles in our sky, the sun and the moon. Everything else are just dots. Planets look like dots, stars are dots. So we've got these two circles. They're both the same apparent size, as we get reminded every time we see a total solar eclipse where one just perfectly fits over the other. But could those two disks also spin in the same period? That's what these guys found out. Scheiner and Galileo. Yeah, they both spin in about a month. Moon does, and so does the sun. But where are those spots? As we observe Mercury moving across the face of the sun, where are the background sunspots?
So I got to stoke this fire. I'll be back in a minute.
When the sun is pretty blank, and it's evocative of a very weird and not good thing that happened some centuries ago, where the sun lost its spots. Normally, I think most people know, the spots, which are storms, come into existence, get more numerous, reach a maximum, and then start fading out, become less numerous until they reach their minimum, and then a new cycle begins. Studies have shown that.
Yes? Is this the Maunder minimum that you're talking about, Bob?
Yes, exactly. And
so
each time there's a new cycle, the polarity, the magnetic fields on the sunspots are reversed. In any case, so we have this roughly 11-year cycle. There's some variability. Sometimes it's stretched out. Recently, it's been weird. We'll get back to that. But then what happened after the sun had been observed for over a century, almost suddenly, from uh, for a whole human lifetime, well, from 1645 to 1710, the spots disappeared. No more spots. The sun's pulse seemed to have vanished. Gone were sunspots, so that observers using better and better telescopes started to doubt there ever were spots. They thought those early observers, Galileo and the others, they must have been seeing things. Come on, spots on the sun. That's how blank the sun became. And at the same time, here's where it gets interesting, Earth started changing. Earth got colder. And by colder, the colonists in America here fighting your ancestors, Paul, during the in the years leading up to the American Revolution, we had the worst winters ever, a time of great hardship. But around the world, it was like that. Fishing colonies in Iceland and Greenland had to be abandoned. The canals of Venice froze. No one had ever seen that. The Thames had ice floating up the river. And it froze solid for a while. Nobody had ever seen things like this. So accompanying the lack of spots was a change on Earth. And we started to realize that, yeah, we're affected by these solar storms in an odd way. I mean, you'd think that when the sun has fewer black spots, it would get hotter. The opposite happens. The spots correlate with more solar activity aimed our way, an increase in the ultraviolet in particular, and through a series of intermediate steps that are still not fully understood. There are changes in our atmosphere, changes in ocean temperature, changes that cause some mischief makers these days to say, there's no real anthropomorphic climate change. We're not changing the climate, we humans, through our carbon releases. It's things like the sun. It's natural. We've always had changes in Earth's climate. And what's all the fuss about? Well, it's true that the sun does affect us, as we've seen, and so do volcanic dust activities.
Yeah.
There are a number of factors, but the carbon dioxide definitely is a big factor, and these days it's the biggest factor in climate change. So there's no getting around that unless you want to deliberately try to ignore it.
And that's what we've got, Bob. You know, from those early sunspot counts that were being done in the early 17th century, we've got this wonderful record. We've also got climate records for that period of time as well. The Age of Enlightenment, everybody was starting to measure everything that they could. So it is quite possible to see, well, yes,
Reds, of course.
Solar activity does affect our climate.
Of course, Reds is capturing this.
Actually, there are these other factors. If you look at the graph,
look, Astronomy Live channel is featuring Reds.
Impact. So let's just have a look at the live stream at the moment, Bob, because we're talking about solar activity. And just above the Y of Canary Islands in the bottom left, we can see that lovely prominence reaching out from the limb of the sun. Now, I would estimate.
Where's Mercury? It's this little dot right here where my mouse
is probably the height of Earth's diameter.
Yes.
I mean, these solar features.
And I've got my Stellarium open.
Enormous, and in fact, a lot of the
show me exactly
sunspots,
where Mercury
when we do
is.
see them, are the size of Earth. You talked about sunspots and the solar cycle, but what is a sunspot to start off with? It's linked to this magnetic field. Is it somehow when it gets knotted up and breaks through the surface, or what's happening physically on the sun when we see a sunspot, and why is it black as well?
Well, it's black because obviously it's not as bright as the surrounding sun. Interestingly, though, if we could transport a sunspot out into space and see it separately, it would be blindingly bright. It wouldn't look black anymore. What appears black and white to us is always a comparison. Our eyes or our film resets to what the ambient current levels are, and then it's always a comparative level. So a sunspot only looks dark because it's not as bright as the surrounding area. It's not as bright because this is an area where, you said it, the magnetic field is stronger at a sunspot. We're talking about 5,000 times stronger. than in the rest of the sun. And this has a constricting effect so that material trying to rise up from below is slowed down and therefore cooled. And therefore, a sunspot is an area where the temperature is cooler, and meaning less luminous. So it's less bright, and that's how it looks. Yeah, it's always a comparison of brightness. We do this in astronomy, but in everyday life. My favorite fact about this is if you compared a black cat as seen in sunlight to a piece of nice white printer paper as seen in the full moonlight. Okay, well, that in full moonlight, printer paper looks quite white, and in full sunlight, a black cat looks quite black. But if you could somehow compare them side by side, a black cat as lit up by the sun is seen next to white printer paper as lit up by the full moon, you know what would happen? Now the printer paper wouldn't be white anymore, it would be black. And the black cat would not only not just be turned from black to white,
Oh, he's
but it would
not.
be so
Reds is
blindingly
not live.
white
Huh.
that you couldn't look at
Oh,
it.
but these
It would
guys are
throw
featuring
shadows
Reds.
all around it.
Maybe he's streaming
It
on
would really
Astronomy
hardly
Live
figure
instead of his own channel.
2,000 times whiter than the so-called white printer paper. So in actual fact, using a photometer, using a measuring device to measure the light, a black cat lit up by the sun is 2,000 times brighter than white paper lit up by the full moon. So, but they only look that way because we're always comparing either with our eyes or with our film or with our photometers, objects lit up with the same kind of illumination.
I can feel an experiment coming on in the Cox household there, Bob. So I just need basically
I feel
a
infinitely
black cat,
little
full
right now.
moon, and a piece of paper. I'll share my results with you.
Yes. So, so now we're looking at the sun looking blank, and so we realize we must be at the minimum part of one of these sunspot cycles. All is well, that's fine, 12-year cycle, but maybe not all. Maybe all is not quite well, because the last few cycles we number them just like we humans like to number everything. And the cycles are, this was cycle number 24 that we were just reaching the end of. And it started late, you know, some 13 years ago or so. The previous cycle, 23, was extended. Its minimum dragged on and on. We had a period of
It's
months
almost
when
in
we
the
had not a
center.
single solar storm. Cycle 24
When I
started
started,
late, and then when it finally came and finally reached its maximum
it was
about
over here
6-7
near
years
this
ago,
sunspot.
that maximum was only half the strength of a normal solar maximum. We haven't seen a cycle this strange in a whole century. So it's late delay. It's very deep and long minimum between cycles 23 and 24. The fact that it failed to reach a normal strength. And now we're seeing more of it, because now the solar minimum, the end of cycle 24, was not supposed to happen for another 2 years. And yet look at the sun right now. We can all look at the sun and we see, no, it's there now. And it's been there, by the way, for a couple of months, where the sun has been essentially empty of spots. So this weirdness on the sun is continuing, so that some solar experts are wondering if this is not the precursor of maybe another Maunder minimum, another extended period of solar inactivity. And we can only see when solar cycle 25 begins, when it reaches its maximum in the mid-2020s, how strong that will be, time will tell. But you know what? If it turns out that the sun is having an extended period of inactivity, it's the best thing that could possibly happen, because, as we've said, this correlates with cooling the Earth, just at the time when climate change will, by and large, warm the Earth. So the sun may be coming to our rescue and buying us time, which hopefully we'll be wise enough to act appropriately with, and use that time wisely.
Yeah, it's that point there, Bob, isn't it? You know, human beings, unfortunately, often only take action when a crisis point reaches its peak. You know, if we this will be like taking the foot off the gas of our response to the climate crisis. But
And you
Bob,
and I
thank
have
you.
done our part. Paul, you and I have taken our foot off the gas. Viewers probably don't know this, but Paul is not just a pilot and was not just an airplane owner, maybe still is, but an aerobatic pilot doing things. I'm a pilot also, and I was until this year an airplane owner for decades. I just sold my plane, by the way. But planes are notorious for being guzzlers of fossil fuels. So the fact that you and I are no longer active doing that means that we are doing our part.
Doing our bit. Exactly.
Yeah, we're doing our
But
Look at how the Stellarium program has the sun moving it almost dead on the same. I'll try to get the size the same. When Red's rhetoric adjusts his camera and then he leaves it still, look at how the motion of the sun moves exactly the same speed and the same direction as Stellarium has it. The Stellarium is just awesome. And I'm pretty sure Reds is in Florida, so he's on the same time zone as I am. A couple of degrees latitude south of me. Look at the motions of his live camera and the motion of the Stellarium. It's got the sun moving exactly the same. And you can count on this, man. Red's rhetoric is no joke. He does this stuff all the time. He films the transit of the space station going across the sun and going across the moon. Wonder if it's warmed up outside. I'm gonna go out and pretty soon I'm gonna go out and see if I can put that filter on my camera and see if I can get a shot of it. Yeah, exactly, influence. Hey, Amy. Yeah, Stellarium is freaking dead on, man. Dead on. Watch when Reds adjusts his camera. Watch the, let me see if I'll zoom out just, there we go. It's pretty close to the same size. And Red's rhetoric, like I said, this is, I mean, this is not a simulation. Red's rhetoric is filming this live right now. Look at how that Stellarium tracks with Red's live stream. That's amazing. What would I do to you if you said you're a flurf? Well, I would tell you to explain the Southern Star rotation. I would ask you to explain what is this black dot going across the sun? Why don't we see it in the sky ever? Good, I'm glad it's a joke. That's pretty awesome. For anybody joining me, newcomer, if you haven't seen, the sun is dead center right in the handle of Libra. Mars is with the Virgin, and Jupiter is in the leg of Ophiuchus, and Venus is in the claw of Scorpio. What a show. Super cool. And Stellarium is in real time, and it's usually set to wherever you are as a location. Of course, you can change your
Hello,
location.
and welcome back to Stu's live coverage of the 2019 transit.
You can change your location on Stellarium. Like if I wanted to, I could go, where was it? Here we are. These guys are, they changed. They were looking at it from Norway. Now we're in Los Angeles here. I was going to say I could go into Stellarium and change my location to Norway, and the position of Mercury would change according to the latitude difference. They're not getting it. Where is it at? From California. I wonder if that's it. Nah. They should be seeing almost the same thing I am in California. Latitude-wise, we're exactly the same. Oh, they've got this line here. This is the, who are these guys looking at? Mercury is almost dead center of the sun. And right here they've got it, it is dead center. It's just about to rise over the center of the sun. Cosmos Sapiens. I'll give you guys a sub. Oh, this is the NASA looped footage. What is the bullseye? That's Mercury. Mercury is almost dead center of the sun right now. Now, when I started this, I think it was maybe close to about an hour ago. Mercury was right about where my mouse is when I started, so it's definitely moved a good bit. And this is supposed to be a 5-hour event, but I'm not going to live stream for 5 hours. And just for anybody who's joining me, I'm using my Stellarium program here, which is a real-time tracker of everything in the sky on the left side here. And the sun is directly in the bar and the handle of Libra. Mars is up here with the Virgin, Jupiter is in the leg of Ophiuchus, and Venus is in the claw of Scorpio. Oh, and Saturn is in Sagittarius. Cool. Look at the alignment. Saturn, Jupiter, Venus, Mercury with the Sun, and then follow that line straight up. Boom, there's Mars. There, all in a nice row, all in one shot of the sky. That's awesome. And over here on the right side is Red's Rhetoric filming live. And look, the Stellarium's got Mercury exactly where Red's Rhetoric is live streaming right now. What's up, Fractal? No kidding. They do indeed. This is one thing they won't touch. Of course, it's all refraction and perspective, man. It's the dome refracting light off swamp gas.
yeah, so I think it's a mix of the constellations which we have now. It is a mix of what earlier have been mentioned in our scriptures, and what we have seen from the other civilization, what we have learned from the other civilization. So it's a mix.
Right.
So for example,
Yeah, no,
for
please
example,
carry on.
this I was mentioning about this 1400 BC thing, but
Yes.
that was the earliest written record. But then we come to now 476 AD, which is the period of Aryabhatta, and he is the most recent astronomer who did the extensive work on motion of the stars and planet, and that is how we started going towards the astronomy, not just the timekeeping.
Right.
So Aryabhatta was the first person who started these things, and then so Aryabhatta, then Brahmagupta, Vrahamira, Lalla, Srivastava. So these were different astronomers. So this period started from 476 AD and it continued till 1200 AD. And after 1200 AD, again, there was a period when there was no. So these astronomers from 476 to 1200, what they did is they wrote what is called Siddhanta, which literally translates to the end of a proof. So
Right.
they were writing the theories, they were describing the theories. They did not have many observational support, but they were just writing the theories.
Okay.
So for example, Aryabhatta calculated the radius of the moon and the radius of the sun, and there were no instruments, and the radius of the so
No,
he
Maria,
mentioned that the radius
floaters
of the moon is
are not
60.5
worms.
times the radius, no, sorry, the distance of the moon is
I have
60.5
I
times
have
the radius of
floaters
the
in my
earth.
eye too. It's the gelatin inside your eye has imperfections. It's not completely smooth, or what's the best word to use there? Your eye isn't just full of like a pure liquid, it's more like a gel. You see the blood flowing in your eyes? Well, actually, that makes sense because there are blood vessels and nerve cells, uh, nerve fibers, actually in front of your cones and rods. So light actually has to filter through blood vessels and nerve cells to get to the back of your eyeball. Yeah. I'm not sure if age has much to do with floaters. Floaters are just imperfections in the gelatin in your eye. Injury, like an eye injury, can have an effect. I think that's why one of the reasons they tell you not to rub your eyes too hard. I think that might have something to do with it. Oh, it is age related? Okay. I've got a bunch of floaters, but for the most part, I don't notice them. Every now and then, if you look at something like a white background, like stare at the wall, and you just relax and try to hold your eyes still, you can see them move around.
Because we've reached a very pivotal moment in this transit of Mercury. What we can see on the screen is reflected in the timing, because at 15:19:46 seconds UTC, Mercury is now at its closest to the sun's center. So we are halfway through this transit. We needed to mark that moment. And you're an important guest. It's why you're here in this segment to mark this. But the point you just made is fascinating to me. That I don't know. There's some big institutions out there who spend an awful lot of money, but the results don't necessarily reflect value for that money. And I think it's I've been following actually the Indian space program over the last decade, and seeing this huge hockey stick graph of what's going on, and it's on the back of a country that you've just been describing there, which educationally has always been very strong in science, mathematics especially, but also engineering. And I've worked with some wonderful, very, very capable engineers in my time from India. And I think it's reflective of that, the value for money that you get. And, so far, the Indian space agencies have not been any less successful. There are always failed missions. NASA have had quite a few of their own of those. But these are still very early days, considering, India was starting from quite a long way back. So how much are you involved with that? Do you get any finance from the Indian space authorities and organizations?
No, yeah. So there is this organization called ISRO, Indian Space Research Organization. So recently we launched a multi-wavelength space observatory, which is called AstroSat. So it observes the sky in ultraviolet, X-ray, and visible wavelengths. So the idea is that there are astronomy institute, and ISRO is helping us in building those instruments, in sending those satellites to the space. So for example, in 2015, ISRO launched AstroSat, and the institutes which were involved in building was IUCA, which is my parent institute, and Indian Institute of Astrophysics, and ARIES, and there are a bunch of other institutes also. So these institutes are not directly funded by the space agency or Department of Space Science, but the fundings come from different sources. But all the institutes, all the agencies work in coherence to build an instrument and then launching it.
And I think that's where a lot of the value comes from, because certainly NASA seems to compete with a lot of people that it should really be working with and collaborating with, rather than competing against them, even though they're not truly allowed to compete against commercial organizations and stuff like that. Kaushal, we've got lots more to talk about, which we won't do now, but you're coming back in, I think it's 40 minutes time. So we'll pick up on some of those other items. Now, one area that we're going to talk about is your particular area of study, which is what? Exoplanet hosting stars. Is that what you're studying?
Right. So I'm working on one field is exoplanet hosting stars, which are M dwarfs, which are cool stars. And obviously we want our parent star to be cooler, not very hot. So just like sun, or cooler than that. So that is one field. And then another field is because of the large survey telescopes, like I was hearing Priya was mentioning that Kepler is one space mission. And there are other space missions which are also space mission and ground-based telescopes also, which are coming up. So I mentioned about AstroSat. So AstroSat is generating like 50 terabyte data per year, but the upcoming telescopes will generate this much data in single night, 15 terabyte per night. So
wow,
we need automated methods.
You're going to have a lot of data to work with. So maybe you can tell us more about that at the top of the hour when you come back. But for now, Kaushal, thank you so much for joining us, and carry on enjoying the views.
Thank you.
While you're gone. Bye-bye.
Yeah, sure.
Now, folks, don't go anywhere. After this short break, we've got SLU astronomer Dr. Mike Shaw, who runs the Nightscapes Astrophotography Club here at SLU. And if you are lucky enough at the moment to have clear skies, unusually for a SLU event, I'm in the UK, I have clear skies, but I'm inside hosting the show. So I can't actually see this myself or photograph it myself. But if you are lucky enough to have clear skies wherever you are, and you fancy trying to photograph the transit of Mercury yourself, then Dr. Mike Shaw is the person to talk to. He's going to be with us right after this very short break. Bye for now.
SLU is your interface to space. Online telescopes situated on mountaintops around the world Await your command to schedule missions so you can capture images of the 1,000 most intriguing celestial objects in the universe. From just $20 per year.
See, look, when they switch over to Greenwich, England, did you notice the orientation change? Because of the different observation points looking at it from Earth, it'll appear in slightly different locations depending on where you are looking at it. It's center at the west coast. Right now it appears to be as close to the center as I think it's going to get from my perspective. And this is Red's Rhetoric down in Florida. He's only a couple of degrees latitude south of where I am. And my Stellarium has it exactly, almost perfectly exactly where Red's is showing it to be right now. I can't zoom in on this anymore, except I can go full screen for a minute. Red's Rhetoric is filming this live right now, no doubt. In fact, I'm pretty sure that this Astronomy Live channel, I think that's his channel actually. This one here, Astronomy Live. Pretty sure that's Red's second or alternate channel.
Hello and welcome back to Slew's live coverage of, I'll say it again, the 2019 transit of Mercury. How cool is this event? Studio are going to quieten down their speaker for us there, but there it is, right on the screen. In fact, what we're getting at the moment, so we're looking at our sun, basically. We'll get our guest on in a second and he'll tell us more about this, but the little white dot which is just in the center, that is the planet Mercury. But just above that,
did he say
another
white
little
dot?
dark patch, which is actually some
there.
some solar features. And loads of people over in Slew chat are talking about the solar prominence that we can see. If you look down at the bottom left-hand corner of the sun, around the 7:30 position, just above the word Canary, you'll
Right
see this
there.
little yellow bulge coming out from the sun, and it's been changing on a minute-by-minute basis. This
Right
is a huge plume of superheated plasma spewing out, being sculpted by the magnetic field lines that are coming out from the sun. Now, if we're lucky, that will survive. So the sun is actually rotating in our view
I wonder if
from
Reds
left
is
to right. So
picking
over the
that up.
next few days, that
Let's see.
prominence may be part of an active region that spins into view, and we might see some other terrific solar features in there. But to talk about those and more, then I'd like to welcome
I
our
don't
next guest.
see
It's
it.
Dr. Mike Shaw, a SLU astronomer. He's an author, and he runs the Nightscapes Club. Hi, Mike. How are you?
I'm just fine,
Should
Paul.
be
How
right
are you
around
doing
here.
over in
I'm
SLU?
not seeing anything.
Very good here. As I said, it's sunny here in the UK, but I'm inside doing the show,
Probably because
not
of the filter
seeing it
he's
outside.
using.
But I understand you're one of the few people in North America who has a clear sky, and you have just snapped your first personal shot using your own camera of the transit. Is that correct?
That is correct, Paul. Happy to say that. It's a brisk 13 degrees Fahrenheit here in St. Paul, but the skies cleared up briefly. I think that would be, I'll have to work out the math on that, but it's like maybe 5 or 10 below Celsius. And we just had a brief parting of the clouds. So unfortunately had the rig set up outside. Definitely talk about that. But yes, it's I've just tweeted out the first image, and hopefully more to come here.
Yeah, I just walked
the end
outside
of
to
the event.
check
But great
to
shots
see if
of
the
just
sun had
before
cleared the
SLU telescope
trees, and I've got a haze
Exactly. I look
starting to
forward to seeing
form,
your
like
shot
a
a little bit later. Now,
bit of a
people who are new to
chemtrail
SLU,
hazy sky is
we've got
starting to
loads of new
form.
members today.
So I'm not sure if I'm going to get to
What
look
is
at
it that
anything on
you
my
do?
own.
What's the Nightscapes bit, Mike, about what you do?
Well, yeah, absolutely. Thanks for asking. And certainly everybody is invited to join our Nightscapes Club. We have a great group of enthusiastic club members in the Nightscapes Club. And what we do there is really focus on
Fractal,
bringing in the
I'm in Eastern Standard
amazing
Time.
deep
If I
sky
remember, the
images
start
that
time
we
was
see through
supposed
the
to
SLU
be, I think,
telescopes, and
7:30
juxtapose
a.m.
those with an equally
Eastern
amazing
was the start time.
foreground or overall night sky.
So
So, for
it's
example,
supposed to be a
we might
5-hour
have one of
event.
the
It's
spiral
10:30 for me right
galaxies that we
now,
can
which
view
means,
through the SLU telescopes, or a
yeah,
gas
we're right
nebula,
about halfway-ish,
or even just some of the stars that we can, binary stars or double stars
maybe a
or
little bit,
star clusters,
maybe a little bit
and we
past
can
halfway.
view those through the SLU telescopes. At the same time, club members learn how to create photographs with their cameras. Not yet with the iPhones, although that's coming along, or the cell phones, that's coming along. But to create these images that you've probably seen of the Milky Way and star trails and meteor showers and all that good stuff, and then know that deep inside those images, that fuzzy spot right there is this amazing thing that you can see through the SLU telescope. So it's really combining those two aspects of our appreciation of space.
Okay, and members, I mean, we're coming up to Christmas time now for those of you who celebrate Christmas. You can do this you can do nightscape photography quite cheaply now, can't you?
Look at
With
how
kind of
perfectly,
consumer grade DSLR cameras and stuff like
look
that,
at how
Mike.
Yeah,
perfectly
that's the best part, Paul. You're
my
exactly right. Is that
Stellarium
really
tracks
almost any.
with
So I teach
Red's
workshops and classes
live
online and in
observation
the
right
field,
now.
and it's amazing how people can just go out and for relatively inexpensively just get an entry level DSLR or mirrorless camera. And since most of those have the ability to manually focus the camera as well as to manually set your exposure, which meaning the ISO and the aperture and the shutter speed, by manually setting all of those things, you can then set them to the right settings to capture these amazing starry night subjects. And what's made that possible over the last 10 years is just advances in camera sensor technology. So just now you can just for example, the image that I just
Yeah,
tweeted,
7:30.
that
That's
image
what I
had
thought.
the same file size as the entire memory of one of my first computers back when I was first buying a computer. It was, I think, it was a choice between a 40 megabyte and an 80 megabyte hard drive, and we went for the 80 megabyte hard drive. Well, these images are 77 megabytes a piece, and when we do time lapses, it's just amazing how things have progressed, and it's that progression that has allowed our viewers, the Nightscape Club members, to easily acquire these amazing Nightscape images, and it's just the whole field has just exploded because of that, really.
And you were talking about, you were talking about the advancement of the technology of
Got a
those
CME
consumer
going on
cameras,
down
and it's
here,
happened so rapidly that one of the great
and it is
benefits of
changing.
that, and I know a lot of Nightscape Club members have done this, is before they decide whether or not Nightscape photography is something they want to get into seriously, then you can actually buy a second-hand. I bought two DSLR cameras, two Canon DSLR cameras off eBay, one for $100 and one for $120, and they are more than capable to do some Nightscape photography and generate some time lapses and stuff like that before, you know, maybe you do ask the family to sell the children or the family car to buy a more up-to-date camera. But, you know, so the entry level really is quite low. And I think one of the things I'd like to point out to viewers, I mean, any viewers who are watching today are obviously interested in astronomy, you know, even on a casual basis, that if somebody wants to take that to the next level, don't land up with the frustration that I had, that so many thousands, tens of thousands, hundreds of thousands of amateur astronomers have had over the years of buying telescopes and landing up not being able to use them, either because they're too complex, because the images that they saw on the boxes were nothing like they can see through the telescope, or if you're here in the UK, we get 2 clear nights a year, we get, you know, a 1 week summer every year, you know, so you land up with all of these telescopes and expensive equipment accumulating under the stairs because it's difficult to set up. You know, half the time you've got to get up for work in the morning, so you can't do that. But Nightscape photography is something that is, you grab your camera, you pick it up, you go outside, sometimes you don't even need a tripod to start snapping away and getting some really quite nice images. So if anybody is kind of wanting to get into this kind of thing, I would really recommend join Mike's Club, buy a cheap second-hand DSLR camera or anything that you can afford. Don't bother with a telescope. And I know this, it'll sound like a sales pitch, but it's not meant to be. This is proper sound advice. Why land up buying an expensive telescope, not using it in your backyard because of all the things I've just said, when actually you could subscribe to SLU for $20 a year and use a half-meter telescope, plus a solar telescope, plus all of the other telescopes that we're launching, plus the new observatory we're launching in 2020 in the Middle East, all for $20 a year. You know, it just doesn't make sense to me. I mean, what are your thoughts on that, Mike? Is that sound advice?
I hope that someone caught that or was able to transcribe that, because that was probably the most articulate summary of the benefit, the dual benefits of SLU coupled with the Nightscape imaging that I've ever heard. I mean, exactly that you have the ability to capture. I mean, the telescope images that I'm able to capture through SLU are far better than anything I have with my own personal telescopes. And you're right, there's a huge overhead I mean, right now it's in November, and you know, we don't have the same duration of nights as in the UK, but it's basically everything. It's cloudy, it's cold. There's a lot of other things to do than to go out to the garage, set up the telescope for an hour, and then have a cloudy night. And so, you know, the locations and the quality and the instrumentation and the ease of use of the SLU instrumentation allows anyone to capture these images to enjoy and to explore and to discover. And like you say, even the most basic, you know, secondhand DSLR, tripod, some basic settings, and you're good to go. I mean, if people show up with the most basic equipment, I just taught a class the other night, Saturday night, and it was cloudy, but we had a bunch of light painting tools that we brought out and had a wonderful time creating our own Nightscape images. So there's really clouds or not, there's something to do to just get outside and appreciate being out in nature in the dark and all the good things that come with that. So that was very well said, what you said, Paul. So that was a good one.
And when you start understanding, you know, some of the lighter technical aspects of Nightscape photography, then you can start concentrating on the art, which I know is your strong point. I mean, your images are just stunning. I mean, it's high level photography in the composition and everything else. But there was one thing you mentioned there, Mike, which I must remind viewers of, and especially new members today, that we've just launched a couple of starter quests. So these quests are activities that SLU members can do. They work through one step at a time. It all relates to using the telescopes and acquiring data and learning a little bit about your targets, learning a little bit more about afterwards. So these starter quests, if you're a little bit reluctant to kind of get into astronomy because you think it's complicated, then these starter quests are going to give you your first steps through slew. And in fact, the first starter quest you could do today, because it's all about capturing an image of the sun through the Canary 5 solar telescope. The second one's about the moon. And then we talk about, Mike, in the third starter quest, we talk about seasonal visibility. Now, this is something that you deal quite a lot in with your nightscape photography, because you're tracking constellations, and well, you're tracking two things, aren't you? The changing sky through the course of a single night, but also over the course of several seasons.
Absolutely, and this is one of the wonderful things I think, especially people who are new to astronomy, new to astrophotography, especially those in the photography community, lack this basic awareness of how the night sky moves. And this is always one of the very first things we talk about. And the SLU 1000 list that is nicely organized on the SLU slide helps with this tremendously. But that's right. And one way, just to, for those of you who are not quite sure what we're talking about here, just think of a revolving rooftop restaurant. So you're in a restaurant on a rooftop that slowly turns in a circle. It's constantly turning, just like the Earth turns on its axis. And as this constant turning takes place, of course, your view changes, just like we do on Earth. And as we enjoy the night sky over the course of even a single evening, just as Paul mentioned, what you see is constantly changing. There's a new object coming up over the eastern horizon. There's something setting in the, or what, you know, depending on which hemisphere you're in. And it's like that during the seasons, as the Earth not only turns on its axis daily during the course of a year, just like Mercury is doing in front of the sun just now, it moves around the sun, and allows us to see these changes over the course of a year. So there's always something to see. And then, of course, over the course of several years, you begin to recognize seasonally available images. Like Orion always reminds me of my undergraduate days walking back from the library, and the Milky Way always reminds me of getting mosquito bitten in the summer. Things like that.
That's not a good memory, that one. Now, Mike, you're going to be joining us again a little bit later, and we'll cover some topics there about specifically how any viewers can safely photograph the transit or the sun at another time, the kind of lens they should be using, the kind of filter and stuff like that. But just in case, this is a long event, so just in case viewers won't be with us later on, you better be, by the way, because we know where you live, we'll come around and find you. But when's your next Nightscapes show? Because you do your live audio show. When is that?
Very, very good, Paul. Thanks for asking about that. So each Tuesday evening, early Wednesday morning UTC, each weekly on Tuesday evenings, 9 p.m. Eastern time, 6 p.m. Pacific time. It goes for about an hour. The great thing about these shows now is that we have this very interactive format, so that we have this the chat feature. So during each show, members will think of a question and post it, and that will then, of course, have other viewers think of related questions, and we just have and I, of course, answer them. And we go through member images. Members will post images during each week, and we'll go through each image and any questions they have. So it's really a very dynamic. It's not just me talking into a microphone. It's a very dynamic.
It is. They're great shows, Mike. They really are great shows. And you're doing one tomorrow night, then?
That's right. It is tomorrow night. So
suddenly, I only just realised what day it was. And also, we've got a special one coming up as well. When I go to Chile, we're going to do a kind of joint one where you're going to kind of give me some instruction on how to use a mirrorless camera down in the southern hemisphere, where maybe catch the large and small Magellanic clouds or something like that. And we can share that online with people and just kind of work through a tutorial. I think that's going to be great fun.
Oh, that sounds like, very. Yeah, in fact, the image I just posted was with a mirrorless camera, so it's easy to use, and we'll talk about how to do things safely. But Paul, that's definitely a show to look forward to. So super excited about that.
Okay, well, I look forward to your show tomorrow, but we're going to see you back here on the Transit of Mercury show a little bit later as well, Mike. But thank you very much for the time being.
Thank you, Paul.
Now, viewers, don't go anywhere as we're still watching this extraordinary. I love this. Is my job the best job in the world or not? It's probably one of the best, isn't it? But look at this. I put this telescope together high up, 8,000 feet on top of a volcano in the Canary Islands. It's totally unmanned. These are robotic telescopes. And here it is, Well, this one actually today is being controlled by our operations manager, Andrew Dumbledon. Sorry, Andrew, forgot to mention you there. But the nighttime telescopes are totally robotic. But look at this. Here we're looking at our local star, the sun, in this full glory with that little dot, that little speck just right of center is the tiny planet Mercury. And so far we've watched it traverse from the left-hand side of the sun's limb all the way over. And we're going to be here until the sun sets in the Canary Islands, which is just before the end of the transit. In fact, we've got about another hour and a quarter from the Canary Islands, but we will still have our Chile feed, live feed from our partners down there, the Astrophysics Institute of the university, Catholic University. They do everything round the wrong way, so all the letters are round the wrong way. Anyway, I am going to be back after this short break with Bob Berman. It's going to be a very short break, so don't go anywhere, because we are going to start looking at the other planets, not looking at them as in live feeds, but we're going to have a comparison of the other planets with Bob Berman in about 60 seconds time. See you then. Bye for now.
Well, the weather has warmed up a little bit outside. I think I might just leave this run. I'm gonna go outside and see if I can put my solar filter on my camera and see if I can get a look at anything. The sun has cleared the trees. The temperature's warmed up a little bit enough for me to be out there and without being too cold. See you, Jeremy. Have a good day. Are you feeling licky today, Fractal? I wonder if I get my filter on my camera. I've got a solar filter. Got a little bit of a haze outside. Hey, can you guys hear me? I'm not sure if I'm muted or not. Let me know if you can hear me. Cool, thanks. I'm gonna get my filter on my camera. I'm gonna walk outside my little tripod, see if I can get a video or a photo or something, see if I can see a little black dot on the sun. Of course, I won't be able to include it in this live stream. I'll have to upload it as a video if I get anything. I walked out there 20 minutes ago and
hello and welcome back to Sleuths Live,
starting to look a little hazy.
2019
Uh-oh, what happened, Reds? Battery exhausted. Oh, come on, Reds, get with it. It's been started at 7:30. It's almost 3.5 hours in. Get a battery, Red. And I'll say again, just in case, hey, LeBabs is here. Yeah, just for anybody who's new tuning into me right now, I've got Stellarium open right now on the left-hand side, so I can track, keep an eye on what Stellarium has to say, what's happening in the sky. And we got Jupiter in the leg of Ophiuchus, Venus is in the claw of Scorpio, Saturn is in the cloak of Sagittarius there. And of course, the Sun is right dead smack in this arm of Libra. And Mars is with Virgo. There's Mars with Virgo. And this Stellarium tracks. So when you zoom into something real close, you can see how it moves. And maybe Reds has a battery. Nope. But a minute ago, if you missed it, when I sized the Sun to exactly the same size that Reds had it, that Mercury was in the exact same location and the Sun was tracking at the exact same speed that it was tracking for Reds. He's down in Florida tracking it live right now. This is a NASA observatory, and they're looping they're looping the footage in high speed. So they just keep starting over, and every time it hits the point where it is right now, they just loop it back. And I'm just piggybacking off of a bunch of other people that are tracking different observatories. And I've got my Stellarium open, keeping an eye on how it tracks with what's supposed to be happening live with everybody else, and it seems to be dead on. Los Angeles should be right there. That's what it looks like. It looks like they... Yep. View from LA. It's right there. Won't be another one for 13 years.
We've then got, don't forget, SLU Classroom and SLU Astrolab. So these are our new educational products supported by the NSF. And the quests there are designed to match the NGSS curriculum. So if you are a science teacher, you'll know what those are. If you're a general teacher, you'll know what those are. But if you're a parent out there, then point your kids' science teachers to SLU so that they can start taking a look at these quests that we're launching, over the remainder of the year. These curriculum-aligned quests that all revolve around live telescopes, and we're building up a lovely little community of teachers who are going to start adding their own material and quests as well. So really, really exciting time here at SLU. Doesn't matter whether you're a student or whether or not you're a general new member, you will find plenty of guidance on how to take your journey of exploration.
Come on,
with SLU.
Reds,
But
get
anyway,
a battery.
I've batted on too much there. We need to get our guest back on, the extraordinary, the one and only, Bob Berman. Hello, Bob. Are you there? Yes, you are.
Yes, I'm here. Thank you, Paul. Yeah.
Now, Bob, for people who haven't seen the earlier segments, what is it you do in normal life?
Oh my goodness. Well, a number of things. I'm the astronomy editor of the Old Farmer's Almanac, going back a quarter of a century. And of course, the almanac, about a third of it is probably tells everybody when the moon and the planets are up and how to view them, each year, each night of the year. And then I'm also an editor, a contributing editor, and longtime columnist with Astronomy magazine. That's been going back, must be a quarter century too. Before that, I was with Discover magazine for almost 20 years. The same publisher. Wrote a column called Night Watchman. That's pretty popular. I've also written 12 published books and do weekly shows on NPR for here in Northeast Public Radio, and lead tours to the northern and southern hemisphere every year, to Alaska for special interest tours. And
I think more than anybody in the world of astronomy, Bob, I have learned more from you than anybody else, especially new
that's so
questions.
kind. Thank you, Paul.
Let's not
I
mention
appreciate that.
Anyway, Bob, we are going to talk. We're running a little bit behind time, but we did want to talk about this comparison of the planets. So here we are, we're watching this tiny little planet, which we've already said is actually smaller than some moons in our solar system. But what else have we got? There are a few other planets in the solar system. How do they compare?
Hey, Fractal, did you see Luke Rudkowski and what's his name? The guy from what's it? Money something money channel. Those two guys went running around Epstein Island for like a half hour. Did you guys see that? They went up to that door. When you say painted door, I don't think it's fake, a fake door that was painted on. They went up and they touched the door. It's not a fake door. I don't think it was fake. It didn't. No, they went up and they checked out that door. I don't think it was fake. I mean, if I'm wrong, I'm wrong, but no, I understand. I understand, Lababs. I didn't say they opened it. But I mean, they went right up to the door to the point where he could put his hand on it, and it didn't appear to be fake, and they didn't say anything about it being fake painted on door. So that's all I know. I did find it pretty odd, though, that they were able to run around that island unchecked for like 30 minutes. They weren't spotted by anyone or stopped by anyone. $11.13? Oh, really? So it's actually going to be 13 years before the next one. I mean, these numbers are kind of amazing. Mercury has an 88-day orbit. It's happening today on Veterans Day, 11/11. The next one's in 13 years. Gotta love them numbers. Yeah, and now the next one's going to be on 11/13, 13 years from now. Wow. You know what? Let's just see where the sun's going to be in Stellarium in 13 years from now. Let's just back this out a little bit and see what we can get here. Where's my time? Let's see. 2019 will go up to 2032. Oh, look. It's exactly the same. almost exactly. Well, Mars moves up the arm of Virgo a little bit. And look, in 13 years, when Mercury transits again, it's going to be right there in the arm of Libra, and all the other planets are going to be almost exactly where they are. Venus is Venus is down here. Okay, so Venus will be almost where Jupiter is now, right in the leg of Ophiuchus. Jupiter is going to be down here, where Saturn is now, just slightly below where Saturn is. The moon is going to be down here in Aquarius. Where is Saturn? Where's Saturn going to be? I'll have to do a search. Wow, that's amazing influence. In 13 years, the sun is going to be exactly where it is in Libra during the next Mercury transit. Wow. Where'd my planets go? Turn my planets back on. Where was that? Equatorial, azimuth, cardinal. Oh, they're on. Wait a minute. Oh, there it is. There's Mercury. Okay, you said that's right. It was 2032 on 11/13. You said, right? There it is. There's Mercury up here. So actually, go back to the 12th. It's down there. Wait a minute. Did it really move that far? 12, 13. Okay, so just below the sun on the 12th, just above the sun on the 13th. So somewhere between the 12th and the 13th, Mercury will cross the sun again. This is, I could probably crank the hours backwards and get Mercury to go right where it needs to be. Let me just put that back. I'm going to get too far off. 11:05. Actually, those are minutes. It's hours. I'm going to go back. Oops. Let me do this. Let's just do it this way. There we go. There it is. Crank the hours back a little bit. 9, 8, 7, 6. There it goes, right there. 5 o'clock a.m. my time. Mercury will transit the sun on the 13th in 2032. There it is. Cool. Cool. 2032. What happened? It's 11, 11, 6, 11. Oh, 13. Let me see. Today is the 11th. There it is. That's cool. Saturn should be by the twins. All right, let me try that again. Okay, so here we are right now. We'll be down here, so we'll go 2032 on 11/13. All right, there's Mercury, and I'll back it up. I think it should be about 5 o'clock in the morning for me. Where'd you go? All right, down here. There you are. So Saturn should be by the twins, and they're going to be over there. There it is. Dead on. You are correct. There's Saturn in Gemini. Awesome. There's Venus right in the bow of Sagittarius. And Jupiter's on the tail of Sagittarius on the next transit of Mercury. How awesome is that? And it's 11 o'clock. Yeah, awesome. That is so cool. Let's see if Red's got a battery going yet. Oh, come on, Reds. Are you back in business, Reds? Let's see what these guys are talking about. Nope, they're taking a break again. Los Angeles. These guys keep bouncing around all over the world, different observatories.
A 5.5-hour show. But let's get straight on with our next guest. It's great to welcome back Dr. Kaushal Sharma from the Inter-University Centre for Astronomy and Astrophysics. And we were talking to him earlier about exoplanets. But now we're going to hone in a little bit on Kaushal's particular area of study. Kaushal, are you there?
Yeah. So when you were talking, I just wanted to make this note. When you were talking to Bob, I was thinking about the ball of hydrogen and helium, and then the planet transiting it. And this is one of, because we just not measure what are the exoplanet, what are the extrasolar planet systems are, but we try to characterize the planets also. And
And you
there
can
is
see
something
that
called
down here
transmission
that
spectroscopy.
there's a
So when
CME
the
happening
planet
down
is
here, and it's
transiting the
definitely
parent
changing
star,
every couple of minutes.
the
When I look
light
at it, it's a
rays which
different
start
shape.
from the parent
So
star,
whatever
they
kind of
pass
filter
through the
these guys are
atmosphere of
using,
the planet, and then it carries the signatures of
it's
the
got the whole sun looking
atmosphere of
pretty
the
consistent,
planet
except
also.
this down
And
here,
that
this
is how
CME
the
has been
atmosphere of
changing
the
over the
planet is
last
also characterized when it is
30 or
transiting
40
the star.
minutes, I guess. I'm not
So
watching the
this
clock,
is, I
but
think, wasn't there a paper released over the last couple of months where oxygen in an exoplanet was discovered
Mercury has
through
moved a lot.
this
When I started
method
streaming,
of I'll
Stellarium
tell you,
had it
people may have
like
missed a little bit of what
way
we
over
heard,
here,
what
right
we
where my
said there,
mouse
because the
is,
music
below
was
this
playing. So
sunspot.
just repeat what you were saying there.
It's like
So
right
we've got
about here when I
an
started. I don't
exoplanet
know how long I've been at it, but
crossing the face of a star. The exoplanet, if it's
it's
got an
definitely moved
atmosphere, what's
across. It's
happening
beyond center
to
point
its
now.
right again
Stellarium's
when
got
we
it
observe
moving
it?
pretty good.
Yeah, so
Was
the light
tracking
passes,
perfectly
the
with
light which
reds.
originates from
Wonder
the
if he
star,
got his shit going
it
yet.
carries the
Nope.
signature of the star, but it passes through the atmosphere of the planet also.
Looks like he's done, I
And when
guess.
it passes, it carries the signature of the planet. And that is how we
Nope,
try
he's
to
still
model
live, I think.
the atmosphere of the planet and characterize it, what metals could be present there, what
Hey,
could be the
Fractal,
situation,
what are you doing
and
over there?
different things about
You
the
playing both
exoplanet,
sides?
the characterization of the exoplanet.
This is absolutely extraordinary to me, given that up until not that many years ago, we didn't even know if any other star had planets at all. But now we're able to take measurements, these spectroscopic measurements of how light is scattered from the star through the atmosphere surrounding another star. And we're able to measure the components of that atmosphere. It's
I caught
utterly
you, Fractal.
extraordinary, isn't it, Korshaw?
Yeah,
You double
this is
dipping?
amazing. And I was just thinking, like
You
our
double dipping the
ancestors, when
live
they used to
streams?
see these celestial phenomena, what they might have been thinking and how we are perceiving these phenomena. So there is a huge difference. Like you might have heard about the story of the Columbus when he was visiting South America, and then he tried
Cosmo
to.
sapiens,
I
they
think there was some tribe,
lost their feed,
and
or maybe
then
they lost
he
a
told that
dead
tribe,
battery too. I
if
don't know.
you do not give us the supply of the food and the shelter,
Uh-oh.
then I'm
we're
These
switching
going
guys
to.
are black. What's going on here?
Yes, right. So, yeah, this is amazing. Yeah.
So I mean, this is why astronomy as a subject is just so much fun as much as anything, because there's always something new to learn, and frankly, it's professional astronomers like yourself who are advancing our understanding of our universe, at a speed which even during the 18th century, they could have only
Tea?
dreamed.
Hell, I'm almost
Huge
ready to
advances
start
were
drinking
made back
wine.
then, but now observational astronomy is reaching a whole new peak. So what is it specifically, Kaushal, that you're working on at the moment?
Yeah. So my work is focused on characterizing the exoplanet host stars. So what we do is we collect the light from the star, we pass it through the spectrograph, and we try to find out the parameters of the star, like what is the temperature, what is the gravity of the star, what metals are present there, the metallicity conditions, and those parameters through the light that is coming from the star. And there is a census, and there is a established fact that most of the planets which are hosted by stars, these are cool stars which are called M dwarfs. So M dwarfs are the most probable targets for hosting the exoplanets. So the probability is around 41% plus minus something. But yeah, those are the most probable targets. And so my focus is my research focus is on estimating the parameters of these stars, and estimating the parameters not just based on the traditional methods, but doing it automatically, so that if there is a large stream of data, we can do it through the automatic methods, and then put a constraints on the initial observations. So for example, various sky surveys like SDSS and LAMOST. So they are providing a huge data. So with these automatic methods, we can put a certain cutoff that we want all the stars which have this much range of temperature, this much range of gravity, and the metals. And then we can further process, we can supply these data to the astronomers who are exactly working on exoplanets, because the host star is host stars determines the property of the whole planetary system, because the whole system is formed from the same protoplanetary disk. So first the star forms, and then the small
Make break
chunks
the
of the
time.
matter start
Yeah,
clustering together,
it'll be an
and then the
Inception
planets form.
stream.
So everything is coming from the same
You could
cloud.
stream
So the
me
star
streaming
property
them,
determines the property of
streaming
the
the
planets also.
observatory.
So
Right.
in that sense, it becomes important.
So,
And
are we seeing that hot, very large stars, which form in incredibly dense clouds of dust and gas, like in the Orion Nebula, are they less likely, are we saying, to have exoplanets orbiting them than smaller, more kind of normal
I'll be back in a second. I'm going to
stars?
go check the sky outside and
yes,
see if it cleared up any.
so with the current observations, yeah, this is the
Deep State will
direction
step
in
in
which
on
the
that.
observations suggest. But as I think you were mentioning previously also, that there are certain biases, like we are not observing the long period planets,
Yeah.
because of our observational constraints. So these suggestions might be constrained because of our observational biases also. But there is no way we can counter for these biases currently. Maybe with the upcoming surveys and upcoming telescopes, for example, TMT 30-meter telescope, with which we can go for the direct imaging, and with the direct imaging we can find out the planets which are smaller in size, larger in size, different variety of planets which we haven't currently found. So yeah,
We,
there are some biases.
But although we've been saying that, the last 15 to 20 years, as far as exoplanet discoveries have been concerned, have been utterly extraordinary, we're we're venturing into actually a whole new era, and I can't help feeling, Kaushal, that you are perfectly placed in a country like India, whose space program is on the ascendance, literally going to the stars, but also the technology. And at your point in your career, you've hit a sweet spot, haven't you?
Yeah. So this is the perfect era, as you mentioned, that observational techniques are also developing. We are building bigger telescopes, and then we are coming into the era of artificial intelligence, where we are applying machine
Of course.
learning and deep learning techniques on the astronomical data. So just to make the process automated.
Yeah.
So yeah, this is the, and of course, from the point of view of human resource also, we are in the perfect spot. So but we need to prepare our human resource for these upcoming challenges, like uh, preparing the optical instruments and reducing the data, because it would require a lot of human resource. So we need to
Well,
prepare our next generation.
hopefully that's what SLU in India and our new
So yes,
SLU
correct.
Classroom and Astrolab
Yeah.
products are going to do to encourage more students, even more students in India, to take an active interest in STEAM subjects. And
Right.
as you say, the huge one of the huge strengths of India's space program is the collaboration that you're seeing across institutions and government organizations. And we don't see enough of that, in other parts of the world. So I think India is the place to watch over the next 3 decades as far as astronomical discovery, and also some of the processing of the huge quantities of data that the new instruments are going to acquire for you. So very, very exciting times, I think, Kaushal.
Yeah. So yeah, this would be this SLU, this new experiment. I really enjoy the concept, and even the history suggests that we were good in theories. For example, the theoretical records goes back to 1400 BC, but the
Mm.
experimental records goes to 1300 AD. So observational wise, we were really behind the West and European countries. So, and the situation still prevails that the observational part and the experimental is still lacking as compared to theory part that is taught in our education system. So SLU can play a great role there.
Well,
And
we certainly hope so. Dr. Kaushal Sharma, you have been an absolute inspiration on today's show, and I know you will have inspired a lot of students, not just in India, but
thank you.
worldwide, watching the show today, who wants to emulate your career and get in on some of this action, where you really have hit the sweet spot of being a professional astronomer. So thank you so much for joining us today, and we hope
Thank
to
you,
see you
Paul.
soon on another SLU show.
Sure. Yeah. Thank you. Thank you so much for
Goodbye.
inviting me.
Wow, what a great set of guests we've had today. Now we've got another coming up, joining the show. We're going to have a very short break now, and then joining us afterwards is Jeff Rich, who is the outreach coordinator at the Carnegie Institution for Science, and he's going to be talking about the overused word, but probably use it because it's true in this context. A fascinating history of the Carnegie Observatories and the Carnegie Institution for Science, and how some of that relates to the planetary transits in history, and the one that we're still watching now. I mean, which way is it? I can always get it wrong. No, it's that way. Look, there's the little planet Mercury crossing the face of our sun. How extraordinary is that? Well, I think it's pretty damn extraordinary. We've seen it cross the sun from the left all the way over to almost the center of the sun. And don't forget, this transit actually of Mercury is one of the longest, because its path has taken it very, very close to the center of the sun, closer than any other transit this century. But we're going to be covering it until the end. But anyway, don't go anywhere. We are going to be right back after this break talking about the Carnegie Institution for Science. Bye for now. Hello and welcome back to SLU's live coverage of the 2019 transit of Mercury. What I believe, and I will debate with anybody who chooses, this is the celestial event of 2019. If there was one event not to miss, it's this one. That is, of course, until the Ring of Fire eclipse on the day after Christmas Day. So anyway, welcome back to SLU. We're having a whale of a time. I can't believe what a whirlwind this is. We've been going now for 4 hours. We have watched the tiny speck of Mercury transit across the face of the sun. I understand that a lot of people are clouded out today. We actually had feeds lined up from Malta and South Africa and the east coast of the United States, but they've all been clouded out. We also understand that even the west coast of America has been clouded out as well. So lots of people watching the live coverage here at SLU. So welcome if you're new. We've got a whole stack of new things launching. We've got a new welcome page. We've got new starter quests. These are activities that help you take your first early steps through learning how to use Slooh. We've got a Transit of Mercury quest launching as well, where hopefully you've all been snapping your images from the Slooh Solar Telescope here. And what that quest will do, it's a special little animation module in there, which will help you create a time-lapse animation of Mercury skipping across the face of the sun. But anyway, that's all for about that. I want to welcome our next guest, very special guest here, Jeff Rich, who's an outreach coordinator at the Carnegie Institution for Science. Jeff, have I got all of that correct?
Yes, specifically we're the observatories of the Carnegie Institution for Science, and I'll talk a little bit about why that is, but yep, thanks for having me on.
Okay, so you look after the observatories as well, don't you? Or you do more than the outreach, don't you?
Yeah, so I'm also an astronomer. That's my part of my day job is doing research with the facilities that we have now, and answering some of the interesting questions that we're studying.
So for people, I think most people around the globe would recognize the name Carnegie, but can you tell us a little bit about where that came from, where that funding came from for these great institutions that you're involved with now?
That's a good question because we get that question a lot, even in the U.S., because Carnegie's name is attached to a lot of things. So he was this very wealthy individual back at the turn of the last century, and he saw fit to giving all of his money away to these great philanthropic enterprises. And one of them was the Carnegie Institution for Science. It was originally called the Carnegie Institution of Washington, just for completion's sake. But the idea was that this large chunk of funding was given to do the best science, the greatest science, whatever that meant, back at the turn of the last century. And in 1904, George Hilary Hale, who was an astronomer at the University of Chicago, had heard about this great new opportunity to fund modern research, and he pitched to the newly founded Carnegie Institution that they should build a mountaintop observatory in Southern California. That was mountaintop observatories were sort of a new idea at the time, and he was really interested personally. George Hilary Hale was in studying the sun, which fits in well with everything going on today. But he saw the opportunity to do more than that. A lot of our work in astronomy is driven by access to the best technology and whatever cool new techniques that we have to study the universe, and that was the case. That's the case now, and that was definitely the case back in 1904 as well.
So it's still about scientific progression and development, and it's also about the new observatories. But the observatory that you just spoke about there, the first one, is that the Mount Wilson Observatory?
Sven, yes. Flynn, that's David Flynn, and I've got that book. It's called The Temple at the Center of Time. It has to do with the Temple of Jerusalem. Absolutely fascinating book. I highly recommend it. It's a pretty amazing book, really. David Flynn is unfortunately, he's passed. He died a young man, but absolutely astonishing research. Sven, did you read that book? And if you did you also read his other book called Cydonia, The Secret Chronicles of Mars? Another amazing piece of work. Influence, what do you mean we? If North America is going to see the transit in 2032, what do you mean we won't see it for another 30 years? We're in North America. I don't understand what you mean by that. I wonder if Red's got his battery up. Nope. You guys are dead in the water. You guys are dead in the water. What's going on here? I need to refresh or something? What about you, Reds? Do I need to reload or something? Oh, Reds is back. North America will not see it in 2032. Okay. Oh, I gotcha. Put up my horizon line. Okay, let's try that again. All right, let's go. Go to 2032. 32 on the 13th. And if I remember, it was like 5 o'clock my time. Should see. I got you. It's all, I already have to crank it up. The horizon. It's going to be below the horizon. 5 a.m. What happened? Where did it go? There it is. Let me just pull this up so it highlights it. Gotcha. Yeah, 5 o'clock a.m. The sun won't rise. It will be below the horizon. Yep, you are correct again, Influence. That's why you're so awesome. You know this shit better than anybody I know. Darn, we will not see it in 2032. Nope, that's correct, Libra. But that's still pretty amazing that the sun's going to be right back where it was in the arm of Libra on the next transit of Mercury. That's still pretty interesting and amazing, I think. $11.39, about $11.35. Okay. Yep, so we probably won't even be alive, you and I, in 2049. Another 30 years for both of us. I don't know about, I'm not sure. You're a smoker, right? I'm a smoker. I probably won't even be alive next time it comes around. I'll be like 80 years old, crusty old smoker if I am alive. Look how far it's moved. Well, I walked outside and I put my solar glasses on and I could see the sun, but without some kind of zoom, I couldn't see Mercury. I was at least able to use those old glasses for the eclipse that you get. I was able to look right at the sun, and I put it on my phone. I was holding it, took a short little video. I wasn't able to get. It's a little bit hazy out there too, and I wasn't able to really get anything. The only way for me to even, I mean, if I try to get, I'll have to mount my phone on tripod, and hold it still, and see if I can zoom in. That's going to take a little bit longer for me to try that. wonder where these guys are. You can see the orientation. Mercury is up here above center and to the right of center on the Stellarium sun. But over here, it's more to the right. It's a little bit lower. I wonder where these guys are, which observatory they're looking at. "13 times every 100 years. Pretty rare thing here. Do not look directly at the sun. Where? You guys gonna tell me where you... Songs, music, songs. You're not gonna tell me where the observatory is? Starlink mission. I wonder what is this? Wait a minute, that's Cosmos Sapiens. I was already on that. Huh. What's going on here? It's the same channel, isn't it? Cosmos Sapiens. Wait a minute, same channel doing two live streams? What's going on here? This is not live, is it? It is live. How is Cosmos Sapiens live streaming twice from the same channel? That's weird. Man, I've got a pack and a half habit influence. I need to knock that shit off. I've already got emphysema. Wake up with a smoker's cough every morning.
Yes, so yeah, I think I sent a picture. There's some
Yeah, we've got an
beautiful
image of this.
telescopes.
It's beautiful. Yeah.
All the telescopes are still there. Actually, this morning they're having a Mercury transit event, which I know you mentioned the places are clouded out. That's actually true here this morning. There's a thick layer of fog. But that's our new observatory, which is also beautiful.
There it is. There's Mount Wilson. Now, what? I collect, Jeff, you won't know this, but I collect antique astronomy books. And one of the things I love doing is watching a live mission, so the live views through the SLU telescope,
I've been to
something like
Mauna
the
Kea.
Andromeda Galaxy or something like that, and then looking through my old antique books. And so many of the old images come from the Mount Wilson Observatory. And it's fascinating to see what we can do with modern technology. The telescopes are smaller, but modern CCD cameras versus the old film cameras that use them. And to start comparing what we can do,
I watched
from
the
a mountaintop
sunrise
in the
over
Canary Islands
the
just
top of the
members
clouds
versus what
from
they
Mauna
were
Kea.
doing, nearly 100 years ago there.
That was pretty awesome.
As you say, this was the first mountaintop observatory, right?
It was definitely one of the first. It was the one with the largest telescopes for the first half of the 20th century, and I went looking through our collection of old images. As you said, it's great to go look at the old images to see if there was any really interesting transit events, which I think by the early 20th century, we just didn't have they didn't get the opportunity to take a nice picture that was in our archive yet. But I was thinking of other stories that relate to what's happening today, and one of them was the discovery of the distance to other galaxies, the fact that we're not the only galaxy in the universe.
Okay,
and one of the most famous images.
This is Edwin Hubble.
Yes, exactly.
And he worked here?
He did, yeah, and it was because he was an astronomer at the Carnegie Observatories. He had access to these telescopes at Mount Wilson that he was able to take these pictures. So I think I sent one of the most famous images along. It's a glass photographic plate, an image of the Andromeda Galaxy that was taken at the 100-inch telescope, which is the largest dome on the right in that panorama I sent you.
Oh, and there it is.
And beautiful. I mean, they're beautiful and really interesting to look at, especially as an astronomer. But this image would have taken hours to make in the time that you could do with a CCD on a smaller telescope nowadays. But cutting edge at the time, the fact that he was able to see all the individual stars, and when this image was taken, we didn't know that that was a whole nother galaxy. It was just a fuzzy blob.
It was called the Andromeda Nebula, wasn't it? At that point.
Exactly.
So what he was able to do then with this huge telescope on a mountaintop was, for the first time, to identify the individual stars making up the galaxy rather than just a nebulous blob. Is that right?
That's basically right. And what's interesting is he didn't know that those individual stars were necessarily part of that galaxy. That was the idea. He was going and looking for novae. Those little N's in that image are stars that appear. The reason there's one crossed out with the bright red word var written is he was imaging this galaxy again and again to actually find things that appeared and disappeared. And that novae disappeared and then reappeared in a subsequent image. And he knew he had something special, that it was one of these variable stars that get brighter and fainter and brighter and fainter, that another astronomer, Henrietta Leavitt, had discovered you could use to measure distances. So once he saw that, he knew something really interesting was going on, that he could measure the distance to whatever this fuzzy cloud was.
Is that what's called a Cepheid variable?
Exactly, yes.
So these are very regular, the way they gain brightness and irrespective of distance. Is that right? They're kind of a standard. Are they the ones called a standard candle?
Exactly. That's the word we use. It's funny because the metaphor we use nowadays is a light bulb, the standard light bulb. It's like if you have a 40-watt light bulb, it's bright if it's next to you and faint if it's far away. And that idea is how we can use anything to measure a distance, a Cepheid variable to measure a distance. If you can measure its period, that's very regular, as you said, from getting bright to faint, then you know how bright it should be. You measure how bright it looks with your telescope, with any telescope, and then you can measure a distance to that.
We've heard of Hubble, obviously. This is the start of him beginning to extend our understanding of the universe, and his studies expanded the universe greatly, didn't it, Jeff?
Yeah, so we went from being one galaxy, the Milky Way, to being a whole universe full of galaxies. And I'm not talking about this just because it's one of the most interesting stories, but it actually relates to the Mercury transit or the Venus transit, where those transits, the transit of Venus, and the idea of using transiting planets, those could be used to lock down the very base of our ability to measure distances in the universe. So starting from the solar system and moving outwards to other stars and then to whole other galaxies, every step of the way is a lot of work and many decades and centuries worth of work for us to be able to really casually throw around millions of light year distances to nearby galaxies.
Exactly. Yeah. So we haven't actually spoken about this. I promised viewers with a lot of our guests that we're going to talk about this, but you mentioned the importance of these planetary transits in establishing distance, and this was done. I mean, these expeditions that were set up in the 18th century were incredibly expensive, on sailing ships halfway around the world to see, to observe a transit of Venus or a transit of Mercury. And it's all hooked up with this thing called parallax, isn't it? So why were they sending people across the world and wanting an observation from over here in the east and an observation from over here in the west? And how did that help us measure distance, Jeff?
So parallax, that thing that you said, allows us to measure distances just by using the position of the Earth as it goes around the sun. That if you're on one end of the sun and you look up at the stars, you might see a slight shift for a star that's closer to you than a star that's further from you. The hard part is figuring out the distance from the Earth to the sun. And my understanding is that Edmund Halley, the famous astronomer, was watching a transit of Mercury, and he had this idea that if you looked at the transit from different places on the Earth, you would see it cross the sun at slightly different times. Very difficult to measure. Not just casually looking at it with the eclipse glasses
Jeff,
or something.
this is the same phenomena that if you hold your finger up in front of you and look what's behind it, if you blink one eye, you'll see your finger in relation to the background in one place, and blink the other eye, and you see it switching back and forth. So that's what they were doing. But of course, what was essential here was the timing. Both of those observations had to be working on the same clock and exactly the same time to make these measurements precise.
It's something that would have been incredibly difficult, as you said, and at a great expense, to have all the same clocks timed exactly the same, taken to different places all over the world without the ability to communicate like we are right now, instantaneously, right? And then you also have to wait for them to get word back to wherever they all started. I think there was a story of astronomer who went to make one of these measurements and was gone for so long that they thought he was just gone forever. In the name of making this really important measurement to pin down the distance from the Earth to the sun using a transit.
So, there were big sacrifices made back then to make observations like this. Technology is advancing. We've moved on from Mount Wilson. Mount Wilson now suffers light pollution. So, what are the Carnegie Observatories, Carnegie Institution for Science? Where are your observatories now? How have you moved forward with technology?
Right. So our offices are still in Pasadena, but a few decades ago we started building telescopes in Chile in the southern hemisphere. And this image is one of the Magellan telescopes. They're two modern telescopes. Have been operating for about 20 years. They have very large mirrors,
It's
6.5
not,
meters.
you're kidding. This is now 20 years old. I still think of this as being the last decade or something. It's crazy.
Well, it speaks to the technology because, the telescopes are amazing, by the way. They incorporated a lot of really new, interesting tech that the scientists and engineers at Carnegie, thought up to make them improve upon the design that we've been using since reflecting telescopes were made 100-something years ago. The other important thing is that we're always building new cameras. So you can have a telescope that's even older than the Magellans or as old as the telescopes at Mount Wilson, but you can build a brand new camera that incorporates new imaging technology, new detectors, new optics, and do cutting edge science with a very old telescope, one that's even older. As you said, light pollution is a big problem for us, but it's not a problem in Chile in the Atacama Desert, where Las Campanas Observatory is, where our modern telescopes are, like the Magellan, one of the Magellans shown here.
And you host other people's telescopes at Las Campanas as well, or is it just Carnegie instruments?
It's primarily Carnegie. There are a couple of telescopes on the mountain that are a bit older, that were built first by the Carnegie Institution. The Magellan telescopes are a consortium, so there are a number of universities and research institutes involved in the construction and the maintenance and in the building of new instrumentation. So there, at any given time, there are new cameras or pieces of cameras being built by other institutions such as the University of Michigan. So the telescopes are used by not just Carnegie scientists, but scientists who are a member of the Magellan group as well. But astronomy is also an international collaboration. I think one good example of that is the TESS telescope, the space telescope that's looking for transiting exoplanets. So I thought of this with respect to the Mercury transit today. There are scientists who try to understand how you would observe planets moving around another star, an exoplanet. As they do so, they might blink out a little bit of light, and you can measure that change in a star's brightness very carefully. There are folks who look to transits of Mercury or Venus to try to predict what we could measure around another star.
Okay.
If you were looking for a planet around a star like the sun, for instance.
So
there,
yep. A lovely test bed to validate, you know, future results maybe from some of these other surveys and telescopes.
And TESS is a good example because it's a space telescope. So there are a number of folks who are using the data and who are looking at that telescope is looking for exoplanets that pass in front of a star and cause a slight dip in its light. And it.
All right, you guys, this has been really cool. I'm gonna I think I'm gonna probably close this down, and I'm gonna take my camera outside, put my filter on it, and put it on a tripod, and just see what I can get. And if I get any video, if I get anything good, then I'll upload it. But this has been pretty damn cool. Looks like there's maybe at least an hour or so to go before Mercury is beyond the sun. So I'm going to go see what I can get outside, even though it's a little bit hazy. Reds is back up and running. You guys can go check out Astronomy Live, or these guys, these astronomers over at this SLOOH, SLOOH channel, whatever that is. You know, just do a search for transit of Mercury, and I'm probably going to go ahead and kill this now. And like I said, if I get anything good on my camera, then I will upload it. This has been fun, and thanks for checking it out, you guys. And I will see you guys next time around.